Hello, welcome to Sean Builds a Lisp. My name is Sean and I am building a Lisp. So, last time we went through and we made our number parser. Previously we had built a very simple string parser, and I suppose it's time to go back and flesh that out. So very similar to last time, I have the ECMAScript grammar specification up here, and I am already scrolled to the relevant string literals section. So pretty much what we've done so far is we are parsing characters between double quotes. So for this language, I'm going to actually skip single quotes for many reasons. Number one of which is that traditionally in Lisp, the single quote character is actually used for the quote macro. And we will want to use that. And secondly, it's just kind of takes away another piece of bike shedding that we might fall into. Which quote style are you supposed to use? So we're going to skip this single string characters portion, but what we do need to do is add our escape sequences. And so to get started, we are going to use the right parsers for the single escape characters, and then we will continue on to parsing hex escapes and Unicode escapes. Alrighty, so let's jump over to our code. Get that guy big. Okay, so this is where we were last time. Let me get my GitHub credentials in there. Cool. All right, so I'm just gonna clear this stuff out. We edited a lot of files last time. Alrighty, so let's grab and look at read string, and we're gonna look at read string.spec, our test. So far we are just checking that we're reading strings. Okay, so what I am going to do here is I am actually going to, where are we? I'm lost. All right, so we want to be in our reader. So here we have a directory for our number parser. I think I'm going to do the same thing for our string reader. I'm using the words parser and reader interchangeably here. So let's do that. And what we'll want to do is grab our read string and pop that in there, and our string read table and pop that in there, and we're gonna have to adjust our requires. So pchar and readchar are now in the parent directory, and in string read table, oh, we don't have anything in our read table yet, so that's great. What we will have to do is adjust some other stuff. So I'm just going to basically, there's a lot of things that are requiring these files elsewhere, and so all of those paths are now broken because I moved these files into the string directory. So I'm just gonna run my tests, and then that'll point me to all of the places that are broken. Alrighty, so where are we? blisp read string. Okay, so we are in, oh, that's tests index.js, helpers, loaders. So right now I'm just looking through this stack trace to find the file, and here it is. It's the read string spec that we actually already have open. So this guy should be in the string directory. And I have a feeling we're also going to be broken in read.js. Maybe not. Actually, it looks like that's all we have to do. Okay, so now we're ready to keep going. All right, so I'm gonna get rid of some of these files that I have randomly open as I was clicking around. Okay, so in this directory, we're going to add a new file, read string escape.js, and we are going to add another file, and let's call this escape read table.js. And so, like our other read tables, we're just going to start with an empty stub. That's an object. And in our read string escape, we'll start with our empty function stub. Function read string escape. And this will take a stream. And so this is our input stream. This is a wrapper around the characters that we're reading. So far, we've only been using strings, but this will also be used for files and whatnot. All right, so read string escape. The second parameter is the current character in the stream. And the last parameter is the value that we have been collecting so far. So if I move this to the right-hand side and we can compare read string, we can see that basically we're going to be inserting this function over here. So as we're going through, this is basically just looping over the characters that are in the stream. And as we're going through, we check our string read table for the current character and see if we have a function for that. And if we do, we return the value of calling that function with the current stream, the current character, and the string content that we've collected so far. And so basically, we're going to modify our string read table such that when we encounter the / character, we will return this read string escape function as our reader here. And so that's what we're looking to do. So escape read table, we're going to add an entry. Sorry, no, not in escape read table yet. We are in string read table. Yeah. Okay, so oops, we will need to escape that. All right, so when we encounter this, we will return read string escape function. And of course, we need to require that. Read string escape. Great. So that's all we have to do to make that run. So let's get a test going here. So, all right. So I've kind of changed how I've been doing my tests in my number test file. So I am going to bring that up on the left-hand side here and do something fairly similar. All right, so I'm going to not command click into that. All right, test/index, this I think is here. It reads the number. I'm just gonna add it reads the string. This could probably be refactored, but let's just keep rolling. And this will be S, and we will return our callback function with S. And so basically this just kind of wraps up the it function. Okay, where were we? We are in read, so I'm kind of comparing read number.spec, and so this is going to be very similar. All right, so let's grab that, and I'm just going to copy pasta right here. And so this will be, instead of number, we are reading a string. So let's put an escape character here. And this will be, it reads the string instead, and that will be simply our stream.input. And this, of course, is also read string. Okay, so if we run this, we are probably expecting a crash because our, I'm gonna move read string escape over here. We're not returning anything from this function, and so we should basically crash, and we do. So let's look at the crash and make sure that, oh, that's not the crash we were expecting. I mistyped something over here. I think I do this every time I type global. I put an E at the end. Okay, let's try this again. Great, and that is what we were expecting. So that function returns undefined, and that's not our string. Okay. So real quick, I'm going to jump into my package.json, and similar to what I did last time is I am going to restrict my test function to only running read string so that we don't have to wait for all the other tests and get bogged down with their output. Okay. One passing, one failing, undefined, great. Okay, so read string escape. Const our read table, we are going to require our escape read table. So basically, this is gonna work very similar. We're going to grab our reader, and that will be read table, and we're gonna pull the function out of the read table for the current character in the stream, which is the second parameter to this function. And what we want to do is if reader, we're going to return value plus reader stream char, and I'm gonna give it the empty string. So basically the way this has been working for other reader functions is that we pass in the value, well, it looks just like this. We pass in the value. This is the string content that we've collected so far, and the result is basically that value plus what we're reading. For our read string escape, I think I don't want to extend that paradigm, and I think that I want the escape reader functions to be pretty standalone. Basically, they're kind of unit functions. They should not be overriding anything, I think. This is always something we can come back to if needed. But otherwise, we are going to... All right, so this won't quite work because right now, char will be the backslash. So let's grab our read char. And so what this does is it returns the current character in the stream and advances the position of the stream by 1. And that is read char. And then we will also want peak char. Whoops. Equals require / peak char. And what peak char does is it returns the current character of the stream. But it does not change the position of the stream, so it doesn't consume any input. So we know that, let's just actually say value plus equals read char stream. And so what this is going to do is currently, when we're in this function, the current char is the escape character. So we'll read that, and oh, we actually do not want to attach it to value. what we want to do is just read it. So basically we want to just, read char stream. So basically all we want to do is advance the current position of the input stream. And then we are going to reassign the char to the new character in the stream. And so this will be our escape code. And then once we have that, that's when we can access our reader. And so our reader will read from the stream and return the appropriate escape sequence. Otherwise, I think we can just return value and resume parsing as normal. So if you escape a character that is not actually an escape sequence, you'll just get that character back. So now if we run this, we expect this to still not work because we'll encounter the escape backslash, and our read table is still empty. So we're not going to return an escape sequence. We'll end up with 0n. So let's run that and verify that that's what we get. It is not. Okay. We got an empty string. Okay, so pretty sure that this function is doing the right thing. So let's look at read string.js. Yes, here we go. So I had originally said that I would return the reader exactly. And so I think that's not actually what we want to do. We will do string content equals reader. All right. So basically, if we have a reader, we are going to defer our string content to that reader. Otherwise, we're going to append our string content with the current character of the stream. And so there we go. We have n. Why don't we have 0? That's interesting. All right, well, I suppose it's time to break out the old breakpoints. And so I'm gonna edit my launch.json also to only run our read string test file. So let's run that, and we will definitely want to break. And see what is actually happening. Okay. Let's look. All right, so current character, it's F, string content. Wait, F. Oh. All right, well, we are parsing this first foo test here. So let's just continue. All right, so now we are, ooh. Oh, I see what I did there. Okay, so we need to actually have quotes to read a string. As it turns out, strings are inside of quotes. I think that that's all we need to do. So let's just run it without breaking and see what happens. Okay, I think that's just our assertion 0, and okay, that is the failure that we were expecting. So what we can do now is jump into our read string escape. Whoops, we want our escape read table, and so basically this will dispatch based on the escape code. So if we put n in here, then we will take a function. All right, so that's all we need. And so basically, oh no, we need, yep, okay. So what we said is we are going to keep this very simple, and we're not going to inject the current value into these functions. So this guy is just going to get, all we need to do is return backslash plus read char stream. So I'm putting these in place. What the heck? What the heck? Let's just put another function in here. Read escape character at module.exports equals function read escape character, and this will take a stream, and all we're going to do is return, it's literally the function we were just writing. Read char stream, we're going to use this a few times, so I'm abstracting it into a function so that we can just simplify our read table a bit. All right, so we'll need read char function, and so we'll require that from the parent directory. And again, this read char function returns the current character of the input sequence and advances the position. All right, so now this is pretty simple, and we'll just be need to require the function we just wrote. So what is this? Read escape character equals require / read escape character. Nope. Read escape. Okay. And read escape character. So that's I always like new lines between things. Well, apparently not always. My spec does not have it. Okay. So terminal. All right, let's run and see if we get what we expected. Oh, that's well, that is just a gosh darn bummer. What do we think is going wrong now? String read table, read string escape, and then if we jump to this guy, we have read string escape. So we'll basically discard the backslash and check the next character in the stream, see if we have a reader. If we have a reader, we'll return value plus the result of that reader. All right, well, let's debug it. Read table equals escape read table, and if we command click into this. Okay, so typo. It's module.exports, not module.export. Okay. All right, so basically what happened here is that our helper function here reads the string, is very helpfully returning us exactly what we passed in, including the quotes, and that's not what we want, so let's fix that. It reads the string, and so what I'm gonna do is just slice this to strip the quotes, and we'll just always assume that we are going to pass in valid data. I'm sure this is going to bite me in the butt very soon. Oh. Huh. Oh yeah, that's pretty much right. Okay, so what I was just thinking about there is when I printed this here, I have double quotes, but it looks pretty weird, but that's actually, like, the quote is kind of our input, and this quote is actually a part of our input string. Okay, so we have /n. Great, new line. So what I'm going to do is I'm just going to rinse and repeat for the rest of these single escape characters. And really simply, let's just copy it. And our escape read table, and paste. So, oops, put that there. And then, whoa, too many. All right. Actually, we can just not have those be strings now because they're real things. All right. So let's just copy pasta. We have n twice. All right. I'm just going to go ahead and delete this first one. All right, so in theory, we should probably write tests for all of these. I suppose we can do that quickly enough. All right, so double quote, escape, B, F, N, R, T, and V. All right, I'm going to also wrap these in another describe. And so what this is going to do is it's just going to partition my test output, maybe just make it a little easier to read and find tests that have failed. So we are going to, let's call this escape sequences. And just wrap all of those functions. Whoops. There we go. Okay, so now all we have to do is, so I'm going to search for search for /n. Oh, /n. There we go. That's what we want. Okay, so we want to have a quote escape and then a / escape. And so basically what I'm doing here is I'm just writing tests for each of these reader macros. And so that way, if we ever break this, we'll just know. All right, so B, F, N, whoops. Okay, N, R, T. Did we miss one? Oh, we have two N's. All right, so I'm just going to keep these. Oops. Keep these lined up with the order. And this is also the order that they're in the spec, so that will be hopefully convenient when we want to go see what's going on. So let's just run our test and make sure that that all works, and it looks like it does. That's nice. So I think I'm going to wrap these in another describe. So this is really just some librarian work on my part, just trying to keep things slightly tidy. It's always a losing battle. Single character escape sequences. And we'll just wrap everything in that. All right, so let's run the test again, and you can see what those describes actually do. And so this is using Mocha. So for each of my tests, actually, let's shrink this down a little bit. We can compare. So I have this function describe module, which is defined right here. And so what this does is it prints out the module that I'm currently testing and requires it for me. So just a little helper function, and then describe call is kind of this guy, and then we also have describe read input, which is spitting out something very similar down here. I'm not sure which one I actually like better yet, so I'm not going to refactor the previous one. And so these describes are here, escape sequences and single character, which is spelled wrong. Okie dokie. So now that we have single character escape sequences, I'm going to flip back to the ECMAScript documentation. And let's see what we have. All right, so decimal digit. That's interesting. So decimal digit is any character 0 to 9. What does that do? I've never seen that before. All right, so let's bring up MDN string escape sequences. Okay, so octal Latin 1 character. I wonder if they have an example. Does not look like it. All right, so I'm gonna actually pop up Chrome just because I want to. All right, what do we want? We want to open up. Oops. DevTools. All right. I just like Chrome's DevTools. So what I'm going to do is I'm just going to try this out. Oh, that's interesting. Bummer. Okay, so basically that's just kind of a fun thing that we're going to have to deal with. So what I'm thinking right now is that I really don't want to go to all the trouble of mapping this out. So let's just see here. Sorry, this is probably pretty small. Let me make this bigger, maybe. Okay, that is not doing. All right, so basically I'm hitting Command plus or Control plus, and it's not getting bigger. How does this actually work in Windows? Zoom. Oh my gosh. Okay, I give up. Anyway, I just wanted to see what octal pattern does, and basically it reads an ASCII character code. So I think I am just going to defer to the JavaScript engine to actually do that. All right, so let's collapse this down and go ahead and do that. Okay. Whoa, what did I just do? All right, did I flip my keyboard layout? Okay. Describe Latin. All right, let's close Chrome now. All right, so where are we? Okay, it's decimal digit. So let's decimal digit code. I don't know what to call this. All right, so let's just go ahead and parse exactly what we were just doing. I'm going to expand this and just so that I can grab this to copy pasta. All right, so what we want to do is we'll just do exactly that. 040 and then, all right, so we're not gonna equal n, we're just gonna do this. So this should be 0, 0 space. Great, okay, so we dutifully ignored that. So I think we have a bunch of utility functions in our read number file that will come in handy. I hope we have a read number file. Yes, we do. All right, so we're going to want to abstract these out. So, whoops, where are we? Read number. All right, so basically what we were doing here is when reading a number literal, if 0 is followed by a B, then we are reading a binary number. And if it's followed by 0, we're reading an octal number. And if it's followed by an X, we're reading a hexadecimal number. So let's just go ahead and abstract this out. And so basically what we did was we have some tests, and based on the test, we have a helper function that reads a bunch of those digits. So I'm going to go ahead and add some functions. Let's is decimal digit, is hex digit. So basically I'm just going to pull these out into modules so that we can require them from the string reader. So what do we have? We have binary digit and is octal digit. Okay, I'm just going to bring up read number here. All right, so let's just make one more. Number codes. This here. Read number. All right, so first we're going to copy these. And so this is just a convenient way to pull the character code because we're doing range comparisons in these functions. So, all right, module.exports equals, and all we're gonna do here, I'm just gonna copy these again and delete the code around them. The hard way. Oops. And of course we need some commas. All right, number codes, and then and then we need this in range function. I'm just gonna make it another module. Why not? So, okay, copy that and put that there, and module.exports equals that. So just make that module, and then we can basically go down the line doing similar things. Actually, I'm just going to cut that. Equals that, and then is octal. Is decimal. Oh, what are you doing over there? And is hex. All right, so now we need to import those things. At const it's binary. All right, so we've got binary. Oops. All right, so I'm just going to do a search and replace on binary to octal on this line, and binary to decimal on that line, and this binary becomes hex. And same thing for capital binary. Binary becomes hex. Binary becomes decimal. This guy is octal. And this guy stays binary. We need a pchar. Oh, wait a second. Oh my goodness. I just undid everything. There we go. Yeah, so in range, we need peak char code here. So peak char code is just like peak char, but instead of returning a string, it returns the character code number. And require that from where it lives in the parent directory. All right, so all right, I'm just going to clear this stuff out. We've got a lot of stuff open now. A little distracting. All right, so I'm going to jump into my package.json, and I'm going to make another function. So basically, I might want to toggle between running all my tests and running the one I'm working on right now. So just going to make two run scripts. So let's do npm run test and make sure we didn't break anything. We broke everything. Oh my goodness. All right, it's decimal digit not defined. All right, so I think I just have some typos. Oh my goodness, I need to get a new mouse. This wheel is just out of control. Is binary, is decimal. All right, let's go back to read number then and see what we messed up. Okay. Oh, our hex digit utilizes is decimal digit. Okay. So we just need to import that. All right, let's run our tests again and see what's broken. And still a lot of stuff in range. Yes, that will come in handy. All right, const in range equals require dot slash in range. All right, and I think we need to add that to all of these guys. Fingers crossed. Still broken. What do we got? 0 is not defined. We need to require that too. Okay, so const 0 and 1. We are going to require from dot slash number codes. And similarly, we will need 0 and 9 here. And in hex, we will need A, F, and the lowercase versions as well. So basically just filling in things that in the other file were all enclosures. And here we need 0 and 7. All right, fingers crossed. Okay, great. We still just have our original failing test. All right, so we are going to go back to our escape read table. Actually, we need read escape character. Okay, so nope. We need read string escape. So many reader functions. Okay, so basically now if we do not have a reader, then we will check to see if char, actually we're gonna do is decimal digit char. Then we will want to basically read 3 decimal digits. So value plus equals read char stream. And I'm just gonna do this in line here. We can refactor later. All right, so if is decimal digit. Actually, let's do this. If not, actually, I'm just gonna fire up a node REPL here rather than messing with Chrome's debugger. So basically, I am just wondering what happens if we don't have a 3-character escape. Oh, it parses it as a Unicode escape. Whoops. Oh gosh, this is just gonna be brutal. I think there are gonna be a lot of edge cases here. All right, so all right. And what if we just do /x? Okay, so whenever we have an x, we have an error if it's not a hexadecimal. /u. All right, so basically I'm just seeing how I can break this thing. All right, this is gonna be fun. I have a feeling I am going to get bored of this and go with a parcel solution for now and track down edge cases later. But let's see what we can do. All right, so first thing I'm gonna do is I'm gonna keep playing. Okay. I think we can get clever and maybe maybe get the JavaScript runtime to do a lot of this work for us. So basically, I think what I'm going to try to do here is just maybe just validate that the string will parse, and then just hand it over to the string constructor function, and that will be way easier. No, actually, that might not work the way I want it to. All right. Just thinking through what the heck I'm doing here. I am kind of curious what will happen if I don't do any of this stuff. String read table. So, oops. String read table. So basically, I'm just going to comment out this and run test current. So this is going to run just the string tests right now, and indeed does not work. Oh. What just happened? Okay. Okay, so the actual is correct for that. Actually, wait a second. I think I'm fooling myself. I'm just gonna fire up the node REPL again and play around. So basically, I'm pretty sure that so if we look at our test case where we have escape 040, which is the space character, I'm pretty sure, actually, I absolutely, all right. I'm just gonna go ahead and I'm gonna input my launch JSON and do a similar thing to what I just did in my package JSON and set up 2 launch configs, one to run all the tests and one to just run the current tests. All right, so let's call this, make this star, and current. All right, make sure we select the current one and jump into read string and just put a breakpoint at the very beginning. And what I'm doing right now is just looking to inspect what we're actually reading here with these escapes. All right, so yeah, great. Okay, so our string content here should actually be 0 quote. All right, let's see here. What if we call string on string content and see? No. Okay. We actually probably do have to really parse all of this stuff. All right, how do we do this? Let's see. No. Raw? No, string dot raw. Is this a function? I can't remember how to use this. Sorry. Let me go find that function. So what I'm looking for now is I just want to, so string.raw is an ES6 thing that will essentially allow you to not have the JavaScript engine do any parsing. So that's how that works. And if we go 0 / quote, we have that. What if we call string on that? So what I'm playing around with right now is seeing if I could trick the JavaScript engine to actually just do this parsing for me, since it already has to. It seems like that is not the case, so we're gonna have to continue parsing, unfortunately. Okay, so string read table, and we do have to read these things. So do we still have our node REPL? I'm just, as I'm continuing to talk, I keep having other ideas that I just want to try out in the REPL. All right, so if we do something, What? Why did it give me back a double escape? Okay, this is gonna be really, really, really fun. Okay, so where were we? Basically, yeah, we're in read string escape. So if we have a decimal digit, all right, let's just keep playing around. So that will give us a space, and if we add another 0, we have space 0, about 004, and we get a Unicode. Whew. Brutal. So if we have 040 and a 0, all right. All right, we're gonna do something just pretty dumb. I equals 0, I is not equal to, so we want to read in 3 decimal digits, and let me just remind myself what happens if there are not 3 decimal digits. 1x. Oh my goodness, it will read it. As a Unicode. Okay, great. Let's continue on anyway. All right, so let's see. All right, so a decimal code is that I is not equal to 3. I plus plus, and then we're going to wrap this guy. And instead of appending to value, we're going to, oops. Oh my goodness, what's happening? Okay. So what I'm doing here is, originally I was just going to kind of read out 3 decimal digits and append them to the string content that we're collecting, but we're going to have to essentially parse the digits, determine if we are parsing a Latin octal code, and if not, we need to convert it into a Unicode code point. Because, sweet. Okay, so decimal code plus equals read char. And then we want to make sure that char is set to the new character. So if not is decimal digit char, then to do, and what do we need to do? We need to convert it to a Unicode code point. Fun, wow, fun, wow. Okay, I'm not going to do that right now. All right, so basically if we encounter a decimal digit and we get outside of this for loop, then we have successfully parsed the decimal code, and let's just to do validate decimal code, and then return value plus equals, we're just going to defer to the string constructor method on this, and if we need to, we can optimize this later. So this will be our decimal code. Wait, is that gonna work? Let's see. Oops. All right, so I'm gonna just pop down here in my node REPL and see if that will do what I think it will do. Oh, that's a string. Shoot, it doesn't. I'm gonna have to. All right, so convert it to a number, and then call string dot. Let's go look this up in the documentation. So, sorry, before we flip back. So basically, we can't use the string constructor because this escape is just not going to do what we think it's going to do. You can see that it's actually escaping the $sign. So what we need to do is value plus equals string dot from char code, and we'll have to convert our decimal code into a number. All right, I'm gonna pop out of my node REPL, and I'm going to run my test and see if this works at all. It looks like it's decimal digit. Need to require it. All right, const is decimal digit equals require slash number slash is decimal digit. And no, still no. Reads the string. Oh. Wait, what? All right, sorry. What is this char code at? Okay, my mouse wheel is driving me crazy. Okay, cannot read property char code at of undefined. So this looks like, oh. Whoops. All right, get out of here. Terminal. That's a problem. This should actually be a stream. All right, shall we try it again? And assignment to constant variable. Oh. All right, so that's just I am plus equaling, and it was const, and that's not a thing you can do. Still more errors. More consts. Where's that? Oh, in my for loop. Hello, Counter-Ren. Sorry, I am terrible at pronouncing usernames, but welcome to Sean Builds a Lisp. My name's Sean, and I am building a Lisp. Okay, so expected. Wait a second. It's not a. Wait a second. Is that right? All right, node REPL again. Let's just do that exactly. Char code number, and our number is 040, and that should be a space, but we get a parenthesis. Oh no, it's not a char code. Oh. From code point, maybe? No. I'm not crazy. 40 is a space, right? Whoops. Okay. These are not char code. Yeah, so a question on the chat, an overview of what I'm trying to do. So what I am doing is I am building a Lisp on top of JavaScript, and the way that I want it to work is essentially Babel's AST nodes in S expression form. So let me just kind of give an example for you. So basically, if you're not familiar with Lisp, it's the language with all the parentheses. It's essentially a bunch of stuff inside of parentheses, and every parenthesis is an expression, essentially, and it's a function application. So if you were to use my programming language once I'm done, and you type something like this, my programming language will compile that down to the following JavaScript. And so basically it's like totally either, you could look at it one of two ways, I suppose, either transparent or opaque, but very straightforward, transferring an S expression into JavaScript so that I can essentially build macros really easily and do a lot of metaprogramming. Motivations originally were F#. Okay, so you probably have heard of Lisp. Motivations were originally that I just kind of got frustrated with TypeScript. Basically, Microsoft tells you how to write TypeScript, and if you try to deviate from what they expect you to do with the language, I've found myself to have a very hard time. That being said, if you stay within the confines, then I love it to death, especially the refactoring superpowers that it gives me. But there are a couple of things when you want to interact with other JavaScript frameworks inside of TypeScript. It doesn't always work out how you would want. And so I started looking into basically writing plugins for TypeScript to do some of the things that I wanted the language to do, and found that the plugin architecture doesn't give enough power to make the things happen that I wanted to happen. And around the same time, there were a bunch of articles that were hitting Hacker News about Lisp, so I kind of learned about that and realized that classic Lisp is the programming languages for programming languages. And so I figured, heck, I want to write a programming language where anybody can come in and do whatever the heck they want, for better or worse. Another question, and ClojureScript. And that's a great question because I have done a little bit of Clojure, not a whole lot, and I really think it's super awesome. Really impressed with Clojure. The thing that still makes me want to write this language is, one, that macros inside ClojureScript are not quite, macros aren't first class in a Lisp in the traditional sense of first class, but they're even like third class in ClojureScript. Macros targeting ClojureScript actually are Clojure macros that expand to ClojureScript. And I'm sure that works totally fine, but I just want it to be my macros to be more integrated. And the other thing about Clojure is that the reader macros are really locked down. I can't remember what they actually call it, but they essentially, the reader macros or user extensible reader macros in Clojure are limited to the Clojure reader will read a form, and your reader macro will get that form exactly. And so it's like only one small step deeper than a Clojure macro. But I want a user of my language to be able to extend the language in any way they want, and I am working through the reader right now. That's actually what I'm doing. I'm working on reading strings. And so basically, the way I've set this up is through read tables, and very similar to the common Lisp reader. And I made one small change that's either brilliant or stupid. But But in Common Lisp, when you set a reader macro, you basically look at the current character and say, when you see this character, call my function with the input stream, like a stream of characters. And then you can like consume those characters and you return a Lisp form. You can either set it as terminating or non-terminating. And basically what that means is that if that character is non-terminating and it occurs in the middle of a symbol, it will not call your macro. It will continue to collect the characters for the symbol. And so the hash symbol is a non-terminating macro. So if you were say that, sorry, I'm just going to write kind of some Common Lisp-ish stuff here. So if I were to type this in Common Lisp, what this does is the hash quote will expand this to function foo, I believe. My Common Lisp is super rusty, so forgive me if I'm wrong. But if I were to write foo hash bar, sorry, foo hash quote bar, shoot, this is a bad example because this is conflating two things. So let's just pretend that I had my own reader macro, or sorry, my own dispatch macro that was hashtag S. And so I'm going to say that hashtag S is going to expand to function, or maybe has hashtag dot. All right, sorry. This is getting totally confusing. Let's just say that I have hashtag S and I have bound hashtag S to expanding in this way. If I set that as a non-terminal reader macro, then when it occurs in the middle of the symbol, it will not expand. So this will not expand. I'll get exactly what it was as a symbol. And that's pretty much all you can do. But by setting up my reader macros, when a reader macro is called, it gets the input stream, the current character, and the value collected so far. So basically what we'll be able to do is essentially for exactly this console.log. So as I'm parsing this console portion will be parsed as a symbol. And then when I get to my dot macro will get the console portion and it can continue parsing. And so in that way, I can expand this to member expression console log called with foo. So it's kind of like a terminating reader macro with superpowers, because not only are you going to terminate the current symbol, but you'll receive that symbol as input and you can manipulate it. So you can almost do like a poor man's binary operator with this. I'm not planning on supporting binary operators in general, but with this reader, you could kind of do it, barring weird space stuff, because I'm kind of hard coding spaces in. So in a nutshell, that is what I am working on. Too much information? Not enough? I don't know. Probably both. All right, so delete my scratch space there. Cool. And so basically right now I am just going through essentially parsing JavaScript strings and struggling with some weird escape sequence stuff that JavaScript does, and I want to match as JavaScript tends to do. Okay, so basically we have escape 040, and that needs to parse to a space. And I thought that this would simply be a character code, but it is not. All right, so I'm going to pop over to the MDN mock documentation and see if I can figure out what's going on and what I'm supposed to do. Oh, That's why. It's an octal, not a decimal. Wait, that is really weird. Actually, my first two streams, sorry, for those of you that don't have the chat open or are watching this later, another question is about using parser combinators. And actually, for my first two streams, I built out a set of parser combinator libraries, and then kind of tried to use them and realized that the state of the parser was captured inside a bunch of closures, and so it wasn't really extendable. So for example, we're working with string escape sequences right now, and I want the user to be able to totally come in and add string escape sequences. And so if I built my string escape parser as a parser combinator, then the state of that parser, the valid character codes, is trapped in the closure of the combinator rather than being extensible. And so at first I thought that I could get around this with dynamically scoped vars, but that didn't work out the way I was hoping. So I bailed out and went with the reader dispatch table, kind of classic common Lisp, because it's been working for a really long time. And with the extension that I was just talking about, I think it will be able to allow the user to do everything that I think is reasonable to do. And of course, all of this is pretty negotiable. I might come back and say, oh, this is dumb, I need to do better. And maybe we'll see. But anyway, the biggest problem that I had with parser combinators was the state being trapped in closures. And also, I'm going to kind of want to memoize the state of my parser so that as I build like IDE features, I can reuse nodes that I've already parsed without having to reparse everything, and basically hopefully make it really snappy, so as you're typing we can do type ahead and all that good stuff. So that's why I bailed out on my parser combinators. In fact, the master branch of my repo still has those parser combinators that I wrote. So basically what I'm looking at here is all right. So I think what the problem I was having is I'm parsing this as a decimal and passing that to number. So if I pass this as an octal to number and grab a code point from that, we get our space. And so that surprises me a little bit because in the ECMAScript grammar documentation, it says that an escape character is followed by decimal digits, an X or a U, or one of these guys. And so basically what I'm taking this to mean is that if it's followed by decimal digits, it is literally a Unicode escape sequence. So I'm just gonna kind of play with that. So if I do /9, sorry. Okay, thanks for the thumbs up. Okay, so if I have a /9, this is kind of weird. This is not behaving at all how I would expect it to. So let's see if we scroll down a little bit. There's some semantic information. Let's see. So right now I'm scanning for the decimal digits to see what in the world they are doing. Okay, that did not help. They don't, where, oh, maybe is it down here? Oh, you know what? I wonder if it is, basically parsing it as hexacode instead. So if we do that, nope. Okay, totally baffled. At any rate, I'm just going to change this to octal digit and move on with my life. All right, so basically we've got a big fat to-do here. If we encounter a character that's not an octal digit, then we need to handle that. And so I'm gonna take a look at the number constructor and see if I can give it a base. All right, let's just open. Okay, I think I'm gonna have to do parsing. Okay, so let's just verify that that's gonna do what we think it will do. Code point and number, oops, parse int, and we've got 040 and base 8. Okay. Whew. I should probably rename this to octal code. All right, so parse int decimal code. Let's just go ahead and rename that to octal code. And come back to running our tests and see if that works. Great. All right. My test is lying though, so basically this should say it reads the string 0 space. And where do we have this? String spec. Reads the string. All right, I'm just gonna futz around with formatting a bit. Oops. And we're looking for a 0 key and a space, and delete that, and cool. All right, just I'm gonna run the test to feel better. Great. All right, so let's rename this to octal. Okay, so let's go back to the string documentation. All right, so we've got our octal character code. We've got our single character escapes. We need a Unicode code point and all right, well, the X will be easier, so let's do that. Okay, I'm just going to do this in line in my escape read table. So if we have an X, then we have a function that gets a stream. All right, so what do we have? All right, so we're gonna read char. Read char. We're gonna read a character from the stream, so and discard it. So we just want to advance the stream's input position. So we're going to require /read char. It's actually in the parent directory. So /read char. All right, so we're at X. We discard the X. All right, so we'll let char equals peak char. Wait a second. Read escape character. We don't need to do this here. Let's just do it. Okay. If not is hex digit char, and we will need to require that. And that's up in number. To do no error. All right, let's start an empty code. Whatever. All right, we'll just do a similar thing. I is equal to 0. We want to read 2 of these guys, I think. Oops. And oops. All right, let's just go ahead and throw our error anyway. New error. Unexpected input, expected. Decimal, got, sure. Code plus equals, oops. Code plus equals, gonna read the char from the stream and reassign the char to the new input of the stream, and we will return our we need to do a very similar thing. So this will be string dot from code point parse int code, and we want base 16 on this guy. All right, so let's grab our spec. I'm gonna put that on the right hand side. Let's just copy that. Pick random code. Let's see what it's supposed to be. All right, so we expect this to come out as 0 at. All right, let's run our tests and see what happens. That's a good point. Is hex digit, and I make this mistake. This function takes the stream and checks the head. All right, so we need read char and peak char. Oh, that's just a typo. My expected result was wrong. And this is lying. All right. Unicode code point. Here's where it gets easy. If you've ever dealt with strings before, my recommendation is to not. Is that even a valid thing? Let's pop into Node and see what happens with that. Yep. If we do 0, 0, 40, it should be at. All right. If it's G, it fails. All right, let's pop back in. All right, so we've got all right, so it looks like Node is only parsing 4 characters. Oh, whoa. All right, so I'm just playing around to see how the parser handles various scenarios here. So this is really quite interesting. So basically, you know what's happening? /000. So this is, I don't think this is as edge casey as I thought. So basically /0, it's just printing the string with the Unicode escape for 0. I think Node is parsing exactly like I am, so that is pretty awesome. Okay, so if we do okay, that is a big relief. Okay, so as my tests, as I was playing around with this, I was like trying out a bunch of tests and like basically accidentally making things look more edge casey than they actually are, because basically Node just parses the digits and then converts them, parses an octal digit and returns the character code. But if you print the Node REPL prints it as the Unicode escape sequence if it's not an actual printable character. Woo, great. So we have to do for you is do something very simple. Very similar to X, except we're just going to read 4 of them. And I can already feel wanting to refactor this, but I'm going to resist that urge. I think this is just gonna work. What a relief. Awesome. Thanks for dropping in, countering, and yeah, I hope to have to see you again. All right, so let's run our new Unicode test and see if that works. Oh, I'm still parsing still trying to parse the hex digit. Okay, so I have a feeling that this Unicode code point is going to change in a future version of JavaScript. So I'm going to pop over to TC39. So if you're not familiar with TC39, it is the committee that decides on additions to JavaScript. And they have a GitHub repo that lists all of the current proposals to the JavaScript language, what's been accepted, and how far along in the process they are. So there are 4 stages. So stage 0 is simply somebody has an idea and suggests that it should be a part of JavaScript. I believe stage 1 is achieved when there is a member of the TC39 committee that supports a proposed addition. And I think stage 2 is reached when there is a reference implementation, maybe in Babel. Getting a little fuzzy. Stage 3 is basically, so at stage 2, essentially it's at the point where you could plausibly use it. And then stage 3 is edge cases have been fleshed out, and there might still be some debate on how the feature would actually work, but it's mostly agreed upon that it should be in the language, I believe, and it's more about how it's going to be implemented. And then stage 4 is that it has been decided how it will be implemented, and it will be introduced in the next release of ECMAScript. And so I'm coming here just to take a peek. I'm pretty sure there's some kind of Unicode thing. Sequence properties in Unicode, property escapes. This might be what I'm thinking of. So now I'm going to be quiet and read. This looks like it's about regex, not string parsing. So let's keep searching. Maybe it's a stage 4 thing. All right, so I'm just going to come back. So we were in active proposals, so that's 1 through 3. Let's take a look at finished proposals and search for Unicode. Oh. All right. Totally not sure. All right, well, anyway, I think what I'm gonna do is put a to do. At least for now, I am matching the behavior of node, it looks like, almost. So let's see. I'm just going to do code point sequences. All right, so the one remaining thing that we differ from node in right now, I believe, is if we do something like 0, 4, where it's not 3 characters. And actually, just for good measure, I'm gonna slap an A at the end. All right, I'm gonna run my tests and see how that fails. All right, I'm gonna pop open a node REPL and just verify. What? Zero 4A. Okay. Maybe that's just the test printer. All right. So it's basically /0004A. No, /u 004A. Okay, so this is in read escape character. So basically, nope, that's not where that is. Read string escape. Those functions are named way too close to each other. Okay, we're just going to all right, so we're just going to break out of the loop and okay, my test is lying to me because I didn't write a handy dandy function for weird escape sequences, but that's what we're actually testing, so that would be hard. Okay. Okay. All right, let's pop back over to the documentation, and I think we've minus whatever this means, I think we have actually met our goals. That's pretty fun. So the one thing that we are differing from JavaScript in is, I think, and I'm not sure how I think it's what I want to do. I'm not sure how it will actually affect the programming language, so I retain the right to go back on this decision. But you can see that in a regular JavaScript string, you need to escape new lines. My parser will just parse those new lines and include them in the string. And I think that's how I want this to actually work, even though it's a little bit different from JavaScript. I think I'm gonna stick with that. So I think that we can call that a stream. All right, look at all those files we added. All right. I'm just going to take a couple minutes here to add these to my repo. Reader number. Let's just look at status, make sure we didn't mess anything up. Okay, looks good. So we're gonna commit this. What did we do? We add string escape sequences to string radar. Okay, we'll push that up. Okay. All right. Well, I think I'm gonna call it a day. So now we are pretty much parsing all of the primitives that we'll need to parse. So next time we get to jump back into our expander and see how we can flesh that out and maybe get one step closer to a real live programming language. As always, thanks for watching. Until next time.